The electrical system generates and supplies electrical energy for operation and control of many airplane subsystems. This presentation covers controls and indicators and system description. During the system description portion, the AC power, DC power, and standby power systems will be covered. First, let's discuss the controls and indicators. The controls and indicators for the electrical system are located on the overhead panel. Let's take a closer look at this panel, beginning at the bottom of the panel and working upward. The lower portion of the electrical panel includes the engine and APU generator switches and associated generator off bus lights. Also shown are the generator bus off lights, transfer bus off lights, and bus transfer switch. A ground power switch with ground power available light and AC ammeters for each engine generator are at the top of the panel. The center portion of the electrical panel includes controls and indicators for the generator drive and the standby power system. First, you see the generator drive oil temperature gauges. Above the gauges are the drive disconnect switches, the drive temperature selector, high oil temperature, and low oil pressure lights. Also included are the standby power switch and standby power off light. The upper portion of the electrical panel includes the battery and galley power switches. Selector switches and power indicators for checking each DC and AC power source are on the upper portion of the panel. A residual volts switch is also located on the panel. Next, let's look at the description of the electrical system. We will first discuss the AC and DC power sources. AC electrical power can be supplied from one of four sources: either engine generator, the APU generator, or a ground power source. DC power is primarily supplied by three transformer rectifiers. Transformer rectifiers, commonly known as TRs, convert 115-volt three-phase AC power to 28-volt DC power. Secondary DC power is supplied by the airplane's battery. Now we'll discuss the AC power system in more detail. The normal AC power sources are the two engine-driven generators. The number 1 engine-driven generator supplies generator bus number 1, and the number 2 engine-driven generator supplies generator bus number 2. The two generator buses then distribute power to the airplane. Ground power, or the APU, can also supply AC power to generator buses 1 and 2. However, only one power source may be connected to a generator bus at any given time. This is referred to as a non-paralleling system. In this example, the engine-driven generators are powering their respective buses. A ground power cart can supply power to both generator buses. On the ground, the APU can also supply power to both generator buses. The generator buses can be powered simultaneously from any combination of AC power sources. In this example, the ground cart is supplying AC power to generator bus number 1 at the same time that bus number 2 is being powered by the APU. Here you can see that the ground cart and the engine generator can supply AC power to opposite buses simultaneously. Now, let's examine the power distribution from the generator buses. Generator bus number 1 powers main bus number 1 and transfer bus number 1. The number 2 generator system is similar. There is a transfer feature in the 737 electrical system. Generator bus number 1 is not powered. When a generator bus is not powered, its transfer bus automatically connects to the powered generator bus. Transfer buses carry their full load after being automatically switched to the alternate source. Most of the electrical system remains powered with the exception of the generator bus and its associated main bus. The correct answer is B. Remember, power sources cannot be connected in parallel. However, they may be used at the same time to power opposite buses. Next, let's discuss the DC power system. There are 3 transformer rectifier units, TR1, TR2, and TR3. The TRs convert 115-volt alternating current to 28-volt direct current. The transfer buses power TR1 and TR2. TR3 is powered by main bus number 2. TR1 supplies DC bus number 1, and TR2 supplies DC bus number 2. TR3 is the primary source of power for the battery bus. It is also used as a backup power source for DC bus number 1 and 2. TRs 1 and 2 also provide backup power for each other. The battery bus also has a backup power source, the battery. The battery can provide power through the hot battery bus to the battery bus. Answer C is correct. The transformer rectifier units convert 115-volt alternating current to 28-volt direct current and supply power to DC bus number 1 and 2 as well as the battery bus. Now we will look at the standby power system. AC and DC standby buses are powered from transformer bus number 1 and DC bus number 1, respectively. The standby buses supply power to some of the essential flight instruments and radio equipment in the airplane. Since the standby buses supply power to essential equipment, they have an alternate source of power from the battery bus. The AC standby bus receives power from the battery bus through a static inverter. The DC standby bus is powered directly from the battery bus. Notice that the battery can also supply power to both AC and DC standby buses. A fully charged battery will provide a minimum of 30 minutes of standby power. Now let's discuss the electrical ground service system. An electrical ground power source or ground power cart can power the ground service bus. A 2-position ground service switch is located on the forward attendance panel. It is magnetically held in the on position. The ground service bus supplies both the passenger cabin lighting and ground service outlets and allows service personnel to clean the airplane without powering other electrical buses. However, if the ground power switch is positioned to on, the number 1 generator bus becomes the primary power source for the ground service bus. The ground service switch will trip to the off position. The battery charger is normally powered by the ground service bus. When the APU or engine generators are the primary power sources, the battery charger is powered through generator bus number 1. Main bus number 2 is a backup should generator bus number 1 fail. Therefore, if either generator bus is powered, the battery charger is also powered. The ground cart supplies power to the fueling panel through a small TR. The fueling panel has an alternate power source from the battery through the hot battery bus. A DC power receptacle located near the battery in the electronic equipment compartment powers all DC circuits normally supplied by the battery. If the battery is depleted, the APU can be started using this outside DC source. Answer C is correct. The ground service bus may be powered by external power or by generator bus number 1. The ground service bus is normally powered in flight. This concludes Part 1 of the electrical system. The system operation presentation will describe the operation of the generator drive, bus switching, standby power, and the AC and DC metering panel. First, let's look at the generator drive. The controls and indicators for the generator drive are located on the forward overhead panel. The generator is driven by the engine throughout its normal operating range, producing AC power at a constant voltage and frequency. The generator drive disconnect switch is a red guarded switch. It is guarded to prevent an unintentional generator disconnect. Positioning the switch to disconnect trips the generator off the bus and disconnects the generator field. Once disconnected with this switch, a generator cannot be reconnected in flight. Oil is used to cool the generator. Oil flows out to an oil cooler. Fan air is used to cool the oil before it flows back in. An oil pressure sensor is located near the in port of the oil pressure line. The low oil pressure light illuminates if the oil pressure is below minimum operating limits. The electrical annunciator and both master caution lights also illuminate. The high oil temperature light illuminates if the temperature of the oil entering the generator exceeds operating limits. The electrical annunciator and both master caution lights also illuminate. Notice the generator drive oil temperature indicator has 2 scales. The inner scale, 40 to 160 degrees centigrade, is used when the generator drive temperature switch is positioned to in. With the switch positioned to in, the temperature of the oil entering the generator is displayed on the indicator. This is the normal position of the generator drive temperature switch. Now, let's look at the rise switch position. The outer scale of the indicator, 0 to 30, is used when the generator drive temperature switch is positioned to rise. The temperature of the oil entering the generator is compared with the temperature of the oil leaving the generator. The rise of oil temperature as it passes through the generator is displayed on the generator drive oil temperature indicator. The caution ranges for both the rise oil temperature and the in oil temperature are marked in yellow. Now, let's examine the bus switching of the electrical system. The bus switching panel is located on the forward overhead panel. The generator switch connects the generator to its bus. The lock toggle switch has on and off positions and is spring-loaded to the neutral center position. To move a lock toggle switch from the neutral position, first it must be pulled out. The off position disconnects the generator from its bus. The blue generator off bus light illuminates whenever the generator is not powering the bus. Momentarily positioning the generator switches to on powers the buses, and the generator off bus lights extinguish. It also removes any other power source connected to the generator bus. AC ammeters indicate the load for each generator. Now let's examine the APU generator switches. The APU is an alternate power source for the generator buses. The APU generator switches operate in the same way as the engine generator switches. A blue APU generator off bus light illuminates when the APU generator is up to speed, but not connected to either generator bus. Placing either APU generator switch to on connects the APU generator power to the respective bus and extinguishes the APU generator off bus light. When the APU generator is connected to either or both buses, it disconnects the previous power source. Now let's tie in the ground power switch. The generator buses can also be powered by a ground power cart. The ground power switch has on and off positions and is spring-loaded to the center neutral position. Illumination of the ground power available light indicates that a ground power cart is plugged into the external AC power receptacle. Placing the ground power switch to on connects external power to the generator buses. However, the ground power available light remains illuminated. This action also removes any previously connected power sources from both generator buses. If the APU is available and connected to a generator bus, the opposite generator bus will remain powered by the ground cart. This permits a no-break power arrangement for the electronic buses when transferring from external power to the APU generator. Power transfer from the external ground power cart to either engine may be accomplished in the same manner, without an interruption or a break to the electronic buses. The bus transfer switch, also located on the bus switching panel, is a two-position switch guarded to the auto position. If a generator bus is not powered, the associated bus off light illuminates. The auto position of the bus transfer switch allows the powered generator bus to automatically supply the opposite transfer bus. The power generator bus then supplies both transfer buses. The off position of the switch deactivates the automatic bus transfer feature and isolates the number 1 and number 2 systems. In this case, generator bus number 2 is unable to provide power to transfer bus number 1. Note that the amber transfer bus off light illuminates, indicating its associated transfer bus is not powered. The bus transfer switch also has two other important features. First, the auto position of the bus transfer switch allows main bus number 2 to provide backup power to the battery charger in the event that the ground service bus is not powered. The off position of the bus transfer switch isolates the main buses and removes the backup power source for the battery charger. The second feature concerns the backup capabilities of the TRs. Recall that TR1 and TR2 are able to provide alternate sources of power for each other, and that TR3 can back up either TR1 or TR2. The auto position of the bus transfer switch closes the TR3 disconnect relay and allows the TRs to provide this backup capability. With the switch in the off position, the TR3 disconnect relay is open, thereby isolating TR1 from TR2 and TR3. The correct answer is C. Placing the right APU generator switch on removes ground power from generator bus number 2 and connects the APU generator to generator bus number 2. Generator bus number 1 will remain powered by the ground power cart. Notice that the blue ground power available light remains illuminated and the blue APU generator off bus light extinguishes. The correct answer is C. When the bus transfer switch is in the auto position and either generator bus is not powered, the powered generator bus is automatically connected to the opposite transfer bus. Now let's look at the standby power system. The controls and indicators for standby power are located on the forward overhead panel. Recall that the normal sources of power for the standby buses are transfer bus number 1 and DC bus number 1. The backup source of power is the battery bus. The battery bus supplies DC power directly to the DC standby bus and AC power through a static inverter to the AC standby bus. Standby power is controlled by a 3-position switch, normally guarded to the auto position. In flight with the switch in auto, if primary power is lost to either of the standby buses automatically transfer to the battery bus. Remember that TR3 is the primary power source for the battery bus, and the battery is an alternate power source. On the ground with the switch in auto, this automatic transfer feature is deactivated and the standby buses will not be powered. This feature prevents inadvertent depletion of the battery. With the standby power switch off, the standby buses are not powered. Whenever the standby buses are not powered, the standby power off light illuminates. The battery position connects both standby buses to the battery bus, regardless of any available power sources or whether the airplane is in flight or on the ground. The battery position of the standby power switch also forces the battery bus to be powered from the airplane battery. Answer C is correct. The primary source of power for the AC standby bus is transfer bus number 1, and the alternate source is the battery bus through the static inverter. Next, let's discuss the AC and DC metering panel. The AC and DC metering panel is located on the forward overhead panel. The battery switch is a 2-position switch guarded to on. This switch controls power to the battery bus. When the switch is on, the primary source of power is TR3 and the alternate source is the hot battery bus. The battery bus will automatically switch to the alternate source if power is lost from TR number 3. When the battery switch is off, the battery bus is not powered. However, if the battery switch is off and the standby power switch is placed to battery, the battery bus will receive power directly from the battery through the hot battery bus. The switched hot battery bus, like the hot battery bus, is always powered by the battery. This ensures an uninterrupted flow of power to certain vital circuits in the airplane when the battery switch is on. Now, let's look at the rest of the AC and DC metering panel. DC loads are displayed on the voltage and amperage meters. The power source to be monitored is selected by the DC meters selector, located below the meters. AC meters are used to monitor frequency and voltage. The power source to be monitored is selected with the AC meters selector below the meters. The galley power switch controls power to the galleys. The correct answer is B. The off position of the battery switch de-energizes the battery bus. Remember, in this situation, power could be restored to the battery bus by placing the standby power switch to battery. This completes the presentation on the electrical system.
Next, we will look at the electrical non-normal indications and procedures. Let's start with the electrical smoke or fire procedure. During flight, an electrical smoke or fire condition occurs. Refer to Chapter 3 in the Operations Manual and study the electrical smoke or fire procedure. Start the machine after you have committed the recall items to memory. After completing the initial steps of the procedure, attempt to determine the smoke source. If the smoke source can be determined, remove electrical power from the specific components affected. Answer B is correct. Placing the bus transfer switch to off isolates the buses and prevents the transfer of power. Placing the galley power switch to off turns off non-essential equipment. If necessary, land at the nearest suitable airport. Now, let's look at the caution lights for the electrical system. A generator bus off light illuminates. The blue generator off bus, both master caution and electrical annunciator lights also illuminate. This indicates the AC bus is unpowered. Place the generator switch on. If the generator resets, the generator off bus light and bus off lights will extinguish. The loss of both engine-driven generators is indicated by the illumination of the transfer bus off, generator off bus, electrical annunciator, and master caution lights. Refer to Chapter 3 in the Operations Manual and study the procedure for the loss of both engine-driven generators. The correct answer is B. Turning off the bus transfer and both electrical hydraulic pumps will prevent high electrical loads while restoring electrical power. A loss of power to the AC standby bus is indicated by the illumination of the standby power off light. Position the standby power switch to battery. The battery will provide standby power for a minimum of 30 minutes. If generator bus 1 or 2 is re-established, the standby power switch is repositioned to auto. A transfer bus off, the electrical annunciator and master caution lights illuminate. This indicates the respective transfer bus is inactive. The procedure has you cycle the bus transfer switch to off and then back to auto. A generator cooling malfunction is indicated by either a drive or a high oil temperature light. The electrical annunciator and master caution lights also illuminate. Disconnect the generator by raising the red guard and momentarily holding the generator drive disconnect switch in the disconnect position. The generator can only be reconnected on the ground. If available, the APU may be started and connected to the unpowered bus. This completes the non-normal presentation of the APU and electrical systems.